Hi everyone, my name is Andrei, and I'll be presenting large language models, our human-level prompt engineers. This is a joint work with Yongchao, Ziwen, Keiran, Silviu, Harris, and Jimmy. So we've all seen the amazing capabilities of large language models, but sometimes it can be difficult to get them to do what we want. So we see here in this task, the goal is to output the sentence, which was the cause. And so if you're giving this to a human, all of these potential instructions would work equally well, but this is not the case for large language models. And you might think of heuristics like maybe this first instruction works the best because it's the most detailed and the longest, but these heuristics don't generally apply. In fact, the process of prompt engineering is very unintuitive, and which makes it very time consuming for developers. And furthermore, it's really not a step we can skip because the difference between a good instruction and a bad instruction can be up to 40% in text accuracy. So what's the solution? Well, we introduce APE, the automatic prompt engineer. So given a small set of input and output demonstrations, as small as 5 or 10, APE can produce an optimized prompt for that task. On a high level, APE begins by taking the user-provided demonstrations and asking a large language model to generate a large set of candidate instructions. Next, it scores all of these instructions, and finally outputs the instruction which has the highest score. So let's walk through a concrete example of how APE works. Let's say we're interested in generating antonyms, and over here on the right is the evaluation template we would be using. So during test time, we would give the large language model all of this text over here, and the model will complete the text where the complete token is. So in this case, it would output indirect, which is the antonym of direct. We want APE to optimize this text in orange such that it optimally elicits this behavior. So how does APE do it? Well, it begins by taking the input, by giving a large language model the input-output examples which were provided by the user and simply asking the large language model, what is a good instruction? So it does this multiple times in order to get multiple different candidate instructions. Afterwards, it scores all of these instructions using the previously mentioned evaluation template. So when we're evaluating an instruction, we simply replace the text in orange with the current instruction we're evaluating, and we evaluate it on a small validation set. In this case, we're using the log probability of the correct answer. So now we can stop here and simply output the instruction which has the highest score. And in practice, we find this works very well. Or we can take the top few instructions and generate instructions which are similar to these. Now that we've generated instructions, we score these as well. And our final optimized prompt will be the best performing instruction out of all generated instructions. So how well does this work? Well, we tested APE on the instruction induction dataset, and we find that it beats human prompt engineers on 24 out of 24 tasks. Furthermore, we see that using APE prompts, we're able to get high performance with model sizes that were previously performing near zero. And we're also able to get very high performance in models that are not fine-tuned for instruction answering, for instruction following. Next, we want to compare it to the best human prompt engineers. So previous researchers found that adding let's think step by step to the end of any prompt elicits chain of thought reasoning, which vastly improves model performance. So this has been seen as sort of the holy grail of human prompt engineering. And we asked APE to also generate a prompt that elicits chain of thought reasoning. And APE was able to do this with no human input in a couple minutes. And this prompt achieved an accuracy of 3% higher than the handcrafted human prompt. Next, we wanted to see how good APE is at steering large language models to be more truthful. A previous approach is that humans have handcrafted a prompt such as this one here, which they give to a model before asking it any questions. Using APE prompts, we were able to achieve answers which are both more truthful and informative. Finally, we've packaged APE up into a nice GitHub, and you're able to use it within a single line simply by providing a small set of input and output demonstrations. We really hope you enjoyed our talk and that you enjoy using APE. Thank you so much for listening.